Who you looking at, Daniel?
Are we the only class?
Oh no, I'm just saying here for the lesson.
Yeah, I am. Or you are.
This is more than
You are the best. Yes. Yes. All right. So we'll go ahead and get started. Like I said, with our second to last lesson here of the year. So 11.3 is over. Yesterday we did probability of like a single event, and today we'll do probability of multiple events. All right. So one important distinction, if you're looking at multiple things happening, is are the events dependent or independent of each other? So dependent would be like the first thing affects the second thing, or the third thing or whatever, and independent, one doesn't affect the other. Okay, so we're going to do a little exercise here at the beginning where we label dependent events as D for dependent, and then I if they're independent. So A says we roll a dice and spin a spinner, right? So obviously those are two different things, so one would not affect the other. So this would be an I kind of scenario. If we draw a card from a deck and then don't replace it and draw another card, that would be dependent, right? Because we have one less card to choose from. Flip a coin again. So that would be the same. That would be the same coin, but does the first thing affect the second thing? No, right? So just because it's the same coin doesn't mean it's dependent. And then, does anybody know what is this a typo? Select a coin from a pike. Does anybody know what that means? I wasn't really sure what that meant. Nobody? Nothing? Okay. I don't know what else it would be though. Maybe a pile. Probably pile, I guess. So select a coin, then you put it back, and then select again. Why would this be independent, but like choice B is dependent? Yeah, you put it back, right? So that's the key phrase that makes it independent. All right. So everybody kind of get that? Does that make sense? All right, but if you do probability of multiple events, whether it's dependent or independent, what you do is you to get the probability of both, you multiply them together. You probably remember that. Again, it's probably been since middle school or so, but you've seen that before. And every time you multiply like a fraction, it gets smaller and smaller, right? So the probability of more things happening in a row always gets less and less likely, just kind of as a general rule. Okay. So example 2, A says you roll a dice, and then you flip a coin. So what's the probability of an even, and then the probability of heads? Okay, so we're going to do probability of even on the dice times probability of heads on the coin. So even would be 3 out of 6 or 1 out of 2 if you want to reduce. And then heads is 1 out of 2 outcomes. So then we multiply, and 1/2 times 1/2 is going to be 1/4. Or 0.25, or if we wanted a percent, 25%. Okay. So again, even though they're both 50-50, the probability of two 50-50 things happening in a row is gets cut in half, right? It's 1 out of 4 instead of 2 out of 4. All right, so you look at the next one and see what you can come up with. So we got 10 Diet Cokes, 5 regular Cokes, 8 bags of Doritos, 12 Cheetos. So what's the probability that if we get a drink and a bag of chips, we select a diet and then a bag of Doritos? So see what you come up with, and feel free to kind of use your calculator so you don't have to worry about reducing or anything like that. All right, so probability of Diet Coke would be 10 out of 15, or 2/3 if you want to reduce fraction. And then we want to multiply that by the probability that we select a bag of Doritos. So if we have 8 bags of Doritos, there were 20 possible bags of chips. So multiplying those two fractions together gives us, 10 over 15 times 8 over 20 is about 0.27 as a decimal. If we want a fraction, we just go to math, turn it into a fraction, and 4 out of 15. So 4 out of 15, or about 0.27. So anybody have any questions so far? Is that making sense? Okay. So then we'll get into dependent events. So it says if A and B are dependent, then the probability of A and B is the probability of A times the probability of, so what's this thing mean? This means the probability of B given that A happened. So that's what that means. Doesn't mean like divided by or anything else. Okay. All right, so let's look at an example together and see what we have. So, so this time we're just thinking about the drinks. All right, so we have 10 diets, 5 regular. So what's the probability that we get 2 regular Cokes? So we want to kind of set this up as probability of regular times probability of regular again. All right, so anyways, probability of regular on the first draw would be 5 out of, 5 out of our total, 15. And then probability on the second draw would be, so now you got to think, how many regulars do we have left? If we drew 1 out, there'd be 4 left now, out of a total of 14 to choose from, okay? So that's the probability of event B given event A. Then we just multiply. Okay, so I already kind of went over that process. So when we multiply here, we should get 2 out of 21. Whoops. Try that again. 2 out of 21, or whatever the decimal is. Everybody with me on that? Any questions? All right, so another common of this type of problem would be select a card and then don't put it back and select again. So go ahead and try the next one. So as you were selecting from a normal deck of 52, what's the probability we get a king and then another king? So probability of king and then probability of king given king on the first draw. What would that give me? All right, so doing it kind of how I showed you on the first one, there are 4 out of 52 original cards that are kings. And then given that we drew a king on the first draw, there'd be 3 left out of 51 cards. Okay, so when we multiply that out, 4 over 52 times 3 over 51 is 0.005 about. I'll turn that into a fraction just to see what it is. Easier to write out. So 1 out of 221. So not very likely. All right, so before we move on, we kind of learned this yesterday. Like, so another approach to this would be kind of what we learned yesterday with the combinatorics. It was our last example. So another approach to this would be, if we think about it as two kings at once, we could set it up like yesterday's just to show you we'd get the same thing. So if we work this out yesterday, at the end of our notes, we would say there's 4 kings to choose from, and we want to know, how many ways could we choose 2, and then that would be our denominator would be 52 originally, choose 2. Okay, so we'll see if this gives us the exact same number. Just to review that from yesterday. So 4 and then choose 2. So that's under math, probability. NCR is option 3. So there's 4, choose 2. Then over 52. Go to math, option 3, under probability. And notice it's that exact same decimal that 4 over 52 times 3 over 51 gave us. Okay, so 2 different ways to do the same thing. Any questions before we move on? All right, so then we have, those were all like this and then that kind of problem. You can also have these that have the word or in it. We talked about this a little bit yesterday, but or means we add them together. And then you have this idea of mutually exclusive or not mutually exclusive. So basically, if they're not mutually exclusive, and we'll look at an example where this will make more sense, but I would circle this minus probability of A and B. What that does is it removes the repeats, or it basically keeps us from double counting. So you'll see what I mean in a second. All right, so we'll get a little bit of each, and then I'll have you guys do a couple to finish out. So pretty short and sweet. All right, so in example 4, students can only take 1 foreign language at a time. Out of a total of 100 students, 37 took Spanish, 15 took French. So what's the probability that a student takes Spanish or French? So we do probability of Spanish plus probability of French. So that would just be, 37 out of 100 plus 15 out of 100, which is 52 out of 100. And then, of course, we could reduce that if we wanted to 13 out of 25. So if it says or, you're just adding them together, right? Which makes sense. All right, so in example 5, we roll a dice 1 time. We roll a die 1 time, okay? So what's the probability of a 2 or a 3? So, we could add each one together. So that'd be 1 out of 6 plus 1 out of 6, which gives me a probability of 1/3, or about 33%. Now, in example B, we'll get our first one that's not mutually exclusive, right? So it says probability of even or greater than 3. So how do I know this is not mutually exclusive? Or like, what would the repeats be? What numbers? So kind of thinking of like a Venn diagram here. What numbers would be in the middle of the Venn diagram that are both even and greater than 3? 4 and 6, right? So our repeats would be 4 and 6. So a total of 2. So we want to take those out at the end, right? Because if we just add even, that's 3 out of 6. And greater than 3, 4, 5, 6, that's 3 out of 6. That would mean that the probability would be 100%, right? Which is not true because, you know, we have numbers that are out of this group, right? So if we don't take out the repeats, which is 2 out of 6, then we're wrong, okay? So 6 out of 6 minus 2 out of 6 gives me 2/3. So sometimes you gotta just not double count, okay? Does that kind of make sense? Everybody with me on that? Any questions? All right, so maybe you and your partner try working through those last 4, all about a deck of cards. See what you can come up with. So you kind of have 2 of each. Two are mutually exclusive. 2 are not mutually exclusive. So if that's a help, I'll go over them in about 2.5 minutes. Sure. All right, guys, I'll go ahead and put them up there, and then we can just see if we have any questions. So, you know, first question would be, you know, if we're looking at heart or diamond, are there any of both? Answer is no on this one. So, you know, you could say, you know, 13 out of 52 are hearts, or maybe make it easier, 1 out of 4. 1 out of 4 are diamonds. So 2 out of 4, or half of our cards are hearts or diamonds. Okay, and there's no repeats. Looking at B, and then heart, it says of a king, should say or a king. So, and kings, and then are there any king of hearts? Yes, there are. There's one, right? So, anyways, so you want to go 13 out of 52 are hearts. There are 4 kings. And then we want to take the repeat out, which would be, you know, there's 1 king of hearts. So 1 out of the 52. So, you know, you have 17 minus 1 would give me 16 out of 52. And then, you know, just reduce from there, which is, my notes over there, 4 out of 13. 4 out of 13. So that one we had a repeat. On C, we don't. There are no king aces, right? There's no combinations there. So this would be 4 out of 52 plus 4 out of 52, or 8 out of 52. And I'll go ahead and give you the reduced version, would be 2 out of 13. Okay, and then last one, ace or black cards. Do you have any repeats? Yes, there are two black cards that are also aces. So anyways, we'd have 4 out of 52 are aces. Half of the deck, or 26 out of 52, are black. And then 2 are black and ace. So take those repeats out so we don't count them twice. So not 30 out of 52, but 28 out of 52, which is going to reduce to 7 out of 13. So went through those pretty quick, but you had time before me. Does anybody have any questions? Are you guys good to go? All right, well, that'll wrap it up. Remember again, Math Excels are optional. Use them as needed. And that's all I got.